Hey everyone, a very warm good evening, and I welcome you all to building a full stack testing CI/CD pipeline, where we have brought you two experts who are going to upskill us today. And without any further delay, I'll bring the first speaker to the stage. Our first speaker is Jim Sheldon, who is a drone.io contributor and senior developer advocate at Harness. Hey, Jim.
Hello, thank you for having me.
Yes. So, Jim, could you please introduce yourself and the session that we are going to do today?
Sure. My name is Jim. I'm a developer advocate with Harness. I live about an hour and a half drive north of Boston. And yeah, I'm excited to be here. I'll be talking about full stack testing and best practices around that, and a bit about Harness products as well to help make that possible. Should I share now? I am sharing.
Yeah, sure.
Excellent. And so with full stack testing, it gives you more confidence in the ability to deliver high quality software and makes it much easier for you to collaborate with your team members. I've already introduced myself. If you've never heard of Harness before, we are a software delivery lifecycle company. So we provide tools for every step along the way, along the path of CI/CD, all the way into production with things like cloud cost management, feature flags, chaos engineering, and even more. So the topic of today is, of course, full stack testing. And we'll have a session from Gayathri. I think maybe you'll introduce her in just a moment. And then after that, we'll have a demo showing how to create a continuous integration pipeline in Harness's platform to run tests for a Marin stack application. And after the session, we'll talk about upcoming quizzes and some potential prizes like an Apple Watch. And I think we bring in Gayathri.
Hi, Jim. Thanks for the introduction. Hello, everyone.
Hello. It's great to meet you.
Nice to meet you too, Jim.
Still here? Yes. Can you give us a little bit of your background?
Sure. So I'm a principal quality analyst from Thoughtworks. As Jim was saying, I recently wrote the book called Full Stack Testing with O'Reilly, and I'm here to talk about the best practices, techniques, and process principles related to full stack testing from the lens of delivering high quality software. I'm, I think, like close to more than a decade and a half with Thoughtworks right now. That's about me.
Well, that's great. I think now I can stop sharing and hand it off to you.
Sure. Let me share my screen.
Yeah, it's here. So, Gayatri, before we go ahead, I have two important announcements to make.
Sure.
First is that post this session, we have a quiz for you guys, and you can find the link to the quiz in the description. The prizes we are giving out gift vouchers, so it's also available in this live chat. So do register. And second thing, we have also come up with a tournament for you to upskill yourselves. So we have this full stack testing and GitOps challenge, which I guess Jim is also going to tell you about. So you can also register for it, and link to that will also be available in the comment section. So you can go register, upskill yourselves, and win amazing prizes. So yeah, Gayatri, back to you.
Sure. Hope you're able to see my screen, everyone. Jim.
Yes, Gayathri, yes.
Okay, got it. Cool. So, yeah, I think I have introduced myself. Apart from being a principal QA consultant in Thoughtworks, I also was the global QA SME with Thoughtworks capabilities, member of the Tech Advisory Board in Thoughtworks India, and also co-authored another ebook, Perspectives of Agile Software Testing. So, going ahead, what the today's agenda? So, we are going to talk about three aspects. First, to begin with, what is software quality? Is software quality even worth the cost and the effort that we put into? And introduction to full stack testing uh, in the lens of process, techniques, and tools and principles. So, starting with, let's align on what is software quality, right? So I mean, it's a very vague term, software quality. Everybody has their own version of defining quality, right? Um, so if we go about asking our end users, like the customers who are actually using the product, they have a set of definition. They have a list, and if you ask the business folks who are actually owning the product, they have a very different requirement. And there are product functionalities, which is like the core service that the product is going to offer to the end user. But is that even enough these days, right? So, like for example, if we are actually selling products online, just being able to search for the product, pay online, and able to purchase the product, it's a functionality. It could be something that is a very novel idea for the business, and also a very useful feature for the end user. But apart from the functionality, the end user and the business have a very huge list of requirements in terms of defining what they see as quality in that product. Some of the things that I've heard in this journey of software development and testing so far are when you approach end users, they'll be like, I want usability, I want 24/7 availability, I want my data to be secure and my privacy to be respected. I want some customer support, I want ease of use. Those are like the end users needs, and if anything goes wrong, I'm sure the end user has their face drowned, and you can actually see them moving away from the product easily, especially in this competitive market, right? Like there are 10 other players in the same zone where your product is actually competing against. And if you ask the business about what do you want, what do you see as quality in your product, and we see requirements like, what I want, reusability. I want no vendor lock-ins to happen. There should be maintainable code. We want to be compliant. Infrastructure cost should be very less. So there's a huge list that comes from the business perspective, which includes cost and effort of development, maintenance, those kind of definitions of quality. So at the end, if we have to summarize, like you see in the bottom, software quality was once equated to a bug-free application. But today, that's not the case, right? It's more, it has become expanded. Functional bug-free application is not enough. And if we have to be competitive in the market, we have to offer a bunch of these other what we call as non-functional requirements or cross-functional requirements, right? So we can also say that subpar quality is equal to running a losing game. So subpar quality, for example, we can argue that time to market is one of the key features, right? Like we want to actually compromise on quality, and we want to quickly produce some outcomes and actually deliver the product to the end customers, and therefore yield revenue, have a sense of whether the product is working or not. So those kind of uh, cost versus quality arguments keep happening. But what we also have to consciously realize is that all those trade-offs that we are making on the quality is only a technical debt. So until a competitor comes across and says that, you know what, other more than your product, I have these many quality features, and then your technical debts will start to eat the product's value, right? So any compromise that we are making on quality in terms of time to market is only a technical debt that needs to be caught up as early as possible so that the competitor doesn't overtake you in the market with that advantage. So it's kind of a running a race where you have to keep catching up, and when is the time that you have to catch up is up to the product, cost, efforts, everything. But underlying theme is subpar quality is always equal to running a losing game. So there are several examples across the globe that show this as evidences, right? So, like a couple of examples closer to home, right? Like for example, Flipkart's Big Billion, they faced a lot of performance problems. So it was one of the um, most awaited event for sales because it was the seasonal festivities happening, and we geared a lot of um, marketing on the social media and everything, and we had a lot of expectations on the product. And on that day there were a lot of performance problems on the site, so it led to a loss of fair share of sales and customer trust to Snapdeal, because Snapdeal was also running sales on the same day around the same festivity event. Yahoo, another example, despite being the first of its kind in the market, right? Like it was one of the first to search, and it gave a lot of, it got a lot of attention. But soon enough, the quality of the search product was let down, and it also encountered the largest security breach in the history. So, as you know, we know that Yahoo how went down in the history. And Ray Chat is another example, an Iranian chat startup. It like startup environment. It was really gearing up for a lot of attention and investments, and again a ransomware attack, and the reputation went down. So again, you have to bootstrap, right? So the credibility that you have built because of all the effort to time to market and everything goes away immediately when quality in some terms has been compromised. So I'm sure all of us would have used a lot of other apps and other websites, and we as end customers also would have seen how frustrated we can become if quality is not actually taken into consideration. Personally, I have definitely had a lot of experience, right? The app used to take me through 100 steps to finish one search flow or one user flow. And I personally would abandon the app because it wasn't usable as an end user. So, in summary, right, quality is quintessential to sustaining a business in the long term. So I want to underline that if you want to sustain in the long term, focusing on quality is a non-negotiable factor. Having said that, how do we build quality into the product? So this is not like some new mantra that I have come up with. This is usually this is a well-known heard phrase, right? Quality is team's responsibility. So building quality um, is something that needs to happen as a continuous process across the software development lifecycle. Starting from requirements analysis, then it needs to include requirements for all the quality dimensions that we spoke about earlier. The design aspect also needs to have all these included into the into carving the design, right? Like it should take X steps to finish a user flow is a requirement, and the design should make sure that it is actually fitting to that requirement. And of course, skillful development contributes to a high quality, obviously, right? Like anything that the clean code, and maintainable code. All of that is something that comes with skillful development as well. And testing for quality, right? Like testing for quality, meticulous testing for all of the quality dimensions individually, and making sure the feedback on those quality dimensions are passed on to the team on a continuous basis will help the team to make sure that they're not missing their quality goals. So that way it is one of the very critical aspect in a software development life cycle. When that is not focused right, um, then I mean, which usually is put in the last phase, or sometimes people, I've seen businesses take it as a a short brush through, just test it quickly and send it to market, very lightly, taken very lightly. But if we are not taking the testing for quality as a serious aspect, then as I said, subpar quality, and then losing the running game is going to happen sooner or later. So today, I think this is the dimension that we'll be talking about: testing for quality, and making sure that full stack testing is actually contributing to high quality, apart from all the other um, areas being taken care of, right? Like requirements has quality, and other aspects are taken care of. So one may actually question whether so much efforts that we put on quality, is it even worth the cost, right? At least businesses come back and ask, we need to put so much cost and efforts into building a high quality product. It actually takes longer, or is it taking a lot of cost? Is it even worth it, right? I'm not sure if people have had to encounter the same question in their jobs, but it's something that I keep hearing often, or it is subtly playing the decisions without being explicitly called out. Um, so, really, is software quality worth the cost? But though we have already established that quality is quintessential for the business to run successfully in the long term, what about the cost factor to build quality in, right? So there is an argument that if you have to build software quality, then it takes more cost and more time. But this is a picture that Martin Fowler, who is the chief scientist for Thoughtworks, has written in martinfowler.com. If you see the blue line that goes on, is the one which is focusing intensively on high quality, and the development efforts that puts quality in the back seat is the brown line. So I think Martin clearly has showed that in the initial few weeks, it does seem like the development efforts is actually slowing down if you have to focus on quality, right? Like there is a point of intersection. um, Before that, we can see that the brown line seems to be contributing much faster, much efficient, but there is a collision point where um, software with high quality starts to shoot up. The blue line starts to actually, uh, with time, it will be easier to develop with quality practices inbuilt into it, and it is also easier to maintain, and cost wise you can actually get more features than the lower quality software. It's mainly, I mean, I'm sure many of us would have been in with some projects like that, where it's very hard to onboard new people. It takes 2 to 3 weeks to onboard new people. There's no safety net of automation tests. The requirements are not clear. So teams have independent goals, quality goals are not aligned. So I think we can see the pattern coming up slowly. The development cost raises, and with time we'll be able to deliver very little features, whereas with teams that have followed all these quality practices have their upper hand because they have the confidence in onboarding new people and starting bootstrapping with the code base because of less maintenance and readability and all of those things, and testing as acting as a safety net. So the cost actually starts to go down for new features, and we'll be able to deliver more features in the time. So that's Martin's view, and I have seen the same thing with multiple clients that I work with as well. So that's a summary of how I think, to answer the question of is software quality worth the cost, and that definitely is with time. If you have to run a long running business, it is fair to invest in quality upfront, and you'll start seeing a lot more benefits with time. Okay, great. So I was mentioning earlier, right? We are going to talk about full stack testing from the lens of delivering high quality software, and we also saw about how testing is one of the critical aspects to pass on feedbacks on the quality goals, and making sure that the team is aligned towards that quality goals, right? So it is not a new term. Testing has been there for a very long time. Now, discipline of testing has been there from ever since the software development uh, practice started. So it is not going to be something that I introduce today in this session, but what we are going to see is how the landscape of full stack testing has evolved today. It's no more, like I said, where we do some API testing, some functional testing, quickly brush off some regression testing, release testing, and then move on, right? It has evolved to have multiple aspects into it. Like, for example, in a modern application which has just the three layers, the UI, services, database, um, each of these layers has different requirements inbuilt into it, like we were talking earlier. So the UI layer has a specific um, requirements like accessibility that needs to actually be tested at that layer, visual testing that needs to happen. And similarly, if you see, there are performance requirements, front-end performance, there's a back-end performance. And if you can take database, data integrity, reliability, and all of those things, has to be focused at each of these layers independently, and also application in entirety. So that's a very um, you know that's a very high level overview of what we're talking about full stack testing, and how to go about it is something that we'll see. But why do we have to focus on all of these elements to attain the value of continuous delivery? So this is another discussion that we spoke about, right? If you have to focus on so many elements on each of these layers, then what are we getting out of it? Why? Um, so one, we have to take the product to the market immediately. So continuous delivery is a value of having such efforts put into all the quality aspects testing. So continuous, as you can see, the continuous integration of code, build, test, and then being able to immediately release iteratively, feature by feature, is going to be the ultimate outcome of focusing on all of those quality elements and being putting in a lot of efforts into uh, full stack testing itself. So, as I was saying in the introductions, there are three aspects that we are going to talk about when it comes to full stack testing. One is process. The other is techniques and tools that needs to be learned for conducting full stack testing, and then the guiding principles that needs to be applied while adopting the process and the techniques. So we'll be going into each of these one by one. So process. So testing testing has always been seen as a siloed activity, right? Like most of the teams sees testing team as a siloed team. Like the development finishes it and the test, and they push it on to the testing team. That's the last team that gets to hear about what functionality has been done. They are always behind, or they are waiting for the release time and getting all the functionalities at once. Just do some 200 to 400 test cases testing and then release it or report bugs. So um, so here the process that we are going to talk about is shift left testing. Again, this is not any new terminology that I'm introducing here. The term has been there for a very long time. This also sometimes referred to as agile testing ways or something. Even in many companies have adopted this. So shift left testing is a philosophy that suggests that most of the testing efforts needs to happen upfront and in a continuous fashion throughout the development cycle. So basically, this is done majorly by adopting CI/CD practices and automating a lot of testing scenarios and cases, but it definitely not restricted to only automation. Fluff testing is about making sure the quality checks for happens much earlier in a iterative fashion on multiple dimensions. We'll get to it a little bit closer in the next slide. So what are we going to gain from this? So basically faster feedback. When we get feedback towards the end, a lot of times the defect has actually percolated much deeper into the code that it is really tough to even curb out any of it, right? the, Sometimes it even asks for some architectural changes, as the defects could be as big as it. I usually see defects as something like there's a well painted wall and you have some scratch in it and you're just putting a patch on it. Sometimes it works very well, the patch seems very well aligned onto the wall, but sometimes it just shows very clearly that you just put a patch onto it. So that's, and also the defect fixing cost actually goes up with the time that it was found, mainly because of the context, right? Like when you are actually developing that feature, you know the context exactly and you know which line of code is actually doing what component integrates with another component. When you have that context, it's actually very easier to fix the defect. But when the context is lost, like the defect is found like really after months together, you might not need, I mean, the person who actually wrote the feature might not even remember the functionality to begin with. It is and also there is a lot of code that has happened over that period of time, that it is almost like a completely new area to learn and to fix the defect. So this is a key crux of shift left testing, and many variations of agile methodologies implement this in various ways through practices. So one variety is the extreme programming practices, the XP practices. So if we look at what are the set of practices that helps in shifting testing to the left, are marked in these cycles. So basically what happens before development, that is in the analysis in the design phase, and what happens in during development and also during the testing phase. So this is an iterative process. This happens for what we call as a user story in agile. So for every user story this happens, and it is at a very small life cycle you can see happening. So quickly going over from the left, so there's a process called Three Amigos process, where the BA, QA, and the dev comes together, analyzes the feature, make sure the requirements are actually fully vetted, there are no edge cases that are left out, and then it moves on to UX and BA design prototype validation. So basically the user experience designer and the business analyst come together, make sure the design prototypes are validated according to the requirements, get the approval, and then there are iteration planning meetings, and then the story kickoff happens within the team. So these make sure the requirements in itself are actually well thought through, and the requirements in itself are not actually missing any huge gaps. So this is, you can view the section as the quality checks on the requirements itself. So that's shifting testing, or what we want to say, testing of the requirements, the quality checks of the requirements itself. The team does this together as an activity in different subgroups. During development, we take the help of tools here. So basically writing unit tests or running UI-driven end-to-end tests using linters. So all the kinds of different kinds of automation tests, and then running it on the local machine to get quicker feedback, running it on the CI to get another feedback, and developer box testing is another activity that is prescribed by extreme programming practices, that gives feedback loops quickly so that the defect doesn't actually percolate into the larger environment where there are multiple people integrating with the code. So the defect is tried to be prevented by getting feedback loops in multiple avenues. And then the manual exploratory user testing happens. So basically, I want to actually clarify that manual exploratory testing is different from manual testing itself. So manual exploration is all about exploring the application and not about verifying that is actually written in the requirements document or the user story. So basically, this is about going ahead and exploring the application to find some of the unknowns that are there, and challenging the business requirements, and having an understanding of the development architecture and everything, and trying to see if there is more to the application behavior that is not known so far. So that happens. So that is another level of practices and feedback that happens. And once that is done, most often that the code or the feature is ready to be deployed to the production itself. So that's the way how testing for different quality dimensions gets pushed to the left of the software development life cycle, like before development and during development, and also after deployment, to do manual exploratory testing and then push it to production. So this helps in, this is a very high level view of extreme programming practices with respect to testing alone, and how it helps to catch feedbacks early in the cycle and also enables continuous delivery that I was talking about earlier. So coming to techniques and tools. So that was process for us, and this is the second thing, techniques and tools. So there are so many testing techniques, right? Like this is like one overview of different testing techniques that can be done to approach different subgroups of software requirements. So I'm not sure if everybody has heard about the FERPS model. So FERPS stands for, it's an acronym basically. It stands for functionality, usability, reliability, performance, and supportability. So this is viewing software requirements holistically into 5 themes. So the model just says the software requirements can be grouped under these 5 themes. And if we have to test these 5 themes, so what are the methods or what are the techniques that can be used to test these requirements? So starting with functionality. So functionality, I think I think most of us will be very familiar. I'm sure a lot of us who do as well manual exploratory testing, like I said. Functional test automation. So functional test automation, here I wanted to clarify that it's not only about the UI-driven end-to-end tests. Functional test automation is an elaborate area which starts from writing unit tests, integration tests, contract tests, UI-driven end-to-end tests, and API tests. So all of these are grouped as functional test automation, and also specifically focusing on data. So data has become one of the crucial elements of any product, and if data is not right, the trust, the integrity of the system is questioned, and focusing on the functional aspect when it comes to data is another. It has to deal with a set of tools, and it has to deal with a set of knowledge that we need to learn while approaching data. So usability, when it comes to usability, there are once again different techniques. So we have visual testing tools these days, which compares the visual aspect of the web against original expected screenshot, or so it's basically expected versus actual of the screenshot kind of a testing technique. Cross browser testing, there are several ways to shift the cross browser testing to the left as well. It can start with the linter actually. So cross browser testing is usually only viewed through the lens of running all the functional UI driven end to end tests on multiple browser, but that's actually an anti pattern. It takes long time, and the value we get out of it is very less as well. But there are a lot of tools and techniques that can be used to shift left the cross browser testing. Localization and international testing is another aspect to that is contributing to usability. So the reason I've listed these techniques differently is because there is a set of knowledge that needs to be acquired to do that kind of a testing, and there are a set of tools that needs to be learned, and the approach is different for each of these elements to cover the major theme. User experience testing. So user experience is different from all the other things, right? Like user experience is actually validating whether the design itself is contributing to usability. So there are different products that actually allows us to do that, and different techniques that allows us to do this, right? Like very simple, there are usability heuristics which needs to be manually tested, which can be manually tested to start with. And there are products which allow real users to test on the prototype and give you feedback. So that's like real time feedback on the prototype of the design itself. There's also A/B testing, which happens on the production to get feedback from two different features, and a lot of techniques there to validate the user experience itself. And accessibility, once again, accessibility has its own complaints related knowledge, accessibility related tools, the functionalities. So there are a bunch of things that contributes to usability testing. When it comes to reliability, I think there is reliability. I hope. I mean, reliability is a vast area here. Unlike functionality and usability, reliability can be a lot of things. Like if we have to talk about the non-functional requirements that actually contributes to reliability, there are many things there, right? But it's all in the first model. They, instead of actually talking about all of them individually, those are clubbed under one theme called reliability. So basically, reliability is to ensure that the application is able to um, deliver what it intends to deliver with the same precision without any errors in case of any unpredicted event also. So basically making it resilient and error free in terms of in cases of such unpredicted events is what that comes under reliability. Like as you can see, there's stress testing that we can do to make sure that application is acting reliable on high performance, one of the unpredictable event that could happen. There's chaos engineering, which is the technique that we could use to ensure that any uh, any kind of experimentation that is contribute to simulate the unpredictable event happens, and making sure that the fixes put in place for that unpredictable event. And infrastructure testing is another aspect that can contribute to making sure that the application is reliable. Infrastructure testing is once again a very vast area, and especially useful when we have to scale the application across geographies, right? Like, or I mean, even within the geography, if we have to scale the application to a lot of users, then you have to have a set of practices to make sure that you can spin up infrastructure with a click of a button. And that means that there is infrastructure as code, and then you have to actually treat the infrastructure code like a software code, and test it, add the automated test for it, scan the infrastructure, and all of those things have to be done to make sure that the application is reliable um, in terms of any unpredictable events with respect to infrastructure. Performance, I think it's very direct. We have back-end performance testing and front-end performance testing. I call it out separately, like I said earlier, because each of them has its own theories about it, and strategies that needs to be applied and tools to be learned. And making sure that is addressed to will ensure that the performance of the application is met continuously, right? So, for example, there is API load testing, and there is also tools like Lighthouse, which does front-end performance analysis. There is even models that are established to measure what to test in front-end performance also. So all of those techniques and approaches will make sure that the performance requirements of the software is addressed by testing for it. So I'm spending a little more time in this slide, mainly because it's important to understand that there are ways to address every aspect of the software requirement in testing. And most of the times it is thought that the certain aspect cannot be tested, and therefore we'll not focus on testing it, and that leads to some production issues. So that's the reason I wanted to go one by one here. So another aspect is the supportability aspect. So if you see first one, like I said, it groups all the software requirements. And once again, supportability is like a vast area. So mostly it talks about the evolutionary code qualities, right? So the making it reusable, making it maintainable, and making it secure. So the code should be secure. So all of those things are actually grouped under supportability. And if you have to test the supportability category of requirements, there are ways like architecture fitness tests. So these kind of tests, so for example, make sure that your package is not dependent on another package, and therefore it is not having that making sure that it is independent and it can be reused, and it's not like tightly coupled. Those kind of architecture tests could be written and run continuously. There are static code analyzers which make sure that the maintainability of code can be ensured at the very early stage itself. Even for security, we have static code analysis specifically. Once again, for dynamic code analysis in terms of security testing, to make sure that the code these are kind of tools and the techniques that are available to ensure that the feedback is gotten continuously. So we'll see that with a couple of examples in the next slide. But these are not one-time activities. All of these that are mentioned here can be plugged into your CI/CD pipelines, and the feedback can be got on a continuous basis, so that like we were mentioning in the shift left process, right, there is feedback loop that is gotten continuously, and the team is able to do continuous delivery. So given these techniques and tools, this is one example, like I was saying. how do you do shift left security testing? Right, like if you combine the shift left process that we mentioned, where the feedback happens at every stage, and if we also combine the previous slide about different techniques that are available for us to test the different aspects of the requirement, we can actually come at a shift left security testing strategy. So if you take security, it is just not about the code being um, the code alone, right? Like there's also functional aspect to it. So there are functional test cases with respect to security. Like for example, there has to be multiple authentication mechanisms, and if you are certain permissions with respect to certain users, like your bank account can be viewed only by you and your account manager. It cannot be viewed by anybody else. Those kind of functional security aspects also, and also there is also the code level um, security practices that needs to be ensured to make sure that there are no vulnerabilities. So there are different techniques there, right? Like SAST, SCA tool, pre-commit hooks. There are also pre-commit hooks that just checks for any private keys or secrets in your code, and then it gives you feedback during the development stage itself, as early as the development stage itself. And then in your CI, you have a lot of tools that can be integrated that gives feedback on a holistic picture of the code. And you can also write the functional automated the security test for the functional test cases that we were talking about. When I'm saying once again functional tests, I want to emphasize again that it is not to be viewed only as the UI end-to-end test, but functional tests can be any of the in any of the layers. Like it can be the micro level test like the unit integration and contract, or it can be the macro level test like the UI end-to-end tests or API tests, or the full end-to-end flow testing also. So there are these kind of tests that can image vulnerability scanning, and DAS techniques are there that gives you feedback within the CA pipeline itself. And then of course manual exploratory testing is going to add a lot of value. I think once again I want to emphasize that manual exploratory testing shouldn't be viewed only from the perspective of functional testing. Manual exploratory testing is very valuable for non-functional requirements testing as well. And especially when it comes to security, there are a lot of aspects like ensuring that the logs doesn't have the PII, like exploring different integration scenarios. How is the data being stored? Is the encryption happening? A lot of things that can be actually explored during manual exploratory testing as well. And and after that there is release pen testing, and there are RASP tools that can actually be integrated in production to look into the runtime security. So basically, there are a lot of acronyms here. I think each of this has a own set of learning that needs to happen. But on a high level, to emphasize on how the shift left testing practices and the techniques can be used to give continuous feedback, and therefore be able to do continuous delivery, is the idea that I wanted to present here. Another example is from the front-end testing perspective. Like during development, there are different kinds of tests, right? Like front-end unit tests, front-end snapshot tests, accessibility tests, front-end performance tests, static code analysis for cross-browser compatibility. And then there are visual tests, cross-browser testing, accessibility functional flows. And then it comes to user story testing, where you choose some process devices, and then release testing. So if you see in before the stage that it goes to the user story testing itself, a lot of feedback is gotten from the during development and by the automated tests that are running as part of the CA itself. So the way I look at manual exploratory testing is the effort has to go into exploring the application, but all the explored functionalities and the regression test cases should be automated. So that way, the manual effort is actually fruitful in finding out some unexplored areas of the application, and those that are explored and we have it as a clear requirement or automated, and the feedback is gotten from the CA and other practices that we spoke about earlier as well. So this is another example, and holistically, if we have to look at it, so there are like many feedback loops in this process. So one, starting from the left hand side, there is feedback loop one, which is on the development. During development, the developers can get feedback from many of the techniques that we spoke about earlier, like the static code, linters, and all of those things, and also by running some the unit tests and all of those things on the developer machine itself. That is feedback loop one, and then it moves to CI, and there is, incremental feedback, as you can see. So each stage will give you incremental feedback on different aspects is the narrative here. So your build and test will run all the micro level tests and give you feedback on the huge set of aspects there. And once it goes there, your macro level test, by macro level test as the end-to-end tests and the API tests, all of those things that runs on a deployed environment, that requires a deployed environment. So you get a feedback loop 3 on those aspects, and then your CFR acceptance test. CFR is nothing but cross-functional requirements. As I said earlier, it is also referred to as non-functional requirements predominantly in the industry. So those feedback is also gotten. So basically, if you see all the feedback quality of all the quality dimensions that we spoke about are gotten in until we, as early as before the self-service deployment pipelines. And after that, we do the manual exploratory testing, make sure that new test cases are found out, and that is actually passed on as the feedback loop. And those test cases need to be automated once again as well. So this is like a view of how continuous testing, the CT, which I think Jess Humble has spoken about a lot in his books as well. Apart from continuous delivery, as one of the key capability of how to do continuous delivery, continuous testing is one of the key capability. And this is an outlook of how continuous testing can happen right from the developer box to how it can be completed with the manual exploratory testing and then pushed to production immediately, right? So once the feedback from the manual exploratory testing stage is completed, it can actually go to production, and that's how we can achieve continuous delivery through continuous testing. So when such intensive practices are mentioned, there is also always a question about is it really that valuable, right? Like, what is the value? Or generally, continuous. I understand continuous delivery is important, and usually the question, how fast is continuous delivery needs to happen? Can it wait for a few months and all of those things? And that's where I think the DORA metrics actually helps in quantifying some of the very essential metrics, which is the 4 key metrics. So by actually, the top 4, the top table represents the 4 key metrics here. The deployment frequency, lead time, mean time to restore change file percentage have to be these, like on demand, less than a day, less than an hour, and 0 to 15%. If the team, and for an LI team, so basically an allied software development team should be able to deploy on demand, that is multiple times per day, and the lead time from commit to pushing it to production should be less than a day. Mean time to restore from a failure should be less than an hour. The change fail percentage of pushing a new code and the integration doesn't hamper the existing code, which is the change fail percentage, should be 0 to 15% if you are an LIT team. So this is an outcome of the research from the Google's DevOps research and assessment team, and ensuring such fast feedbacks, which we spoke about in the previous slides, make sure that the desired deployment frequency, the change file percentage, and lead time actually falls under this category. So you will be able to do on-demand deployment because you have the feedback checks or the quality checks that are happening within your cycle itself for every particular commit that is going on, and you're in a position to continuously deliver. And also the lead time from commit to production, as you can see, that the entire pipeline doesn't take like more than an hour or maximum an hour. And also change file percentage will be as low as what it is desired, because you have your tests validating from all the quality dimensions perspective, not just on functional aspect, but also on the non-functional requirements perspectives. And therefore, you know that the feedback that you have gotten is in entirety. And the team can have the confidence to just push the code directly and know that there are no integration issues. Such practices actually make sure that the delivery happens quickly, and the DORA metrics is also related to org's performance, the organization's performance, and how the organization is able to increase their revenue, and everything is related in the research, and it is a very good read. If I mean, Accelerate is also one of the books that talks elaborately on that. So these practices not just actually help the product to be successful, but also slowly contributes the organization structure success, increase in revenue for the organization, and all of those things. I mean, it's a chain always, right? Like one action is related to another action, and this is how all of those full stack testing techniques, tools, process relate to the entire ecosystem. And lastly, the aspect is the 7 guiding principles in testing. So when applying all of those process and the techniques and tools, these principles have to be kept in mind. So the principles are essential because we are generally, we need a mindset, right? We are humans and we need a mindset to approach the problem. So it cannot be on a mechanical fashion. So how do we even deal with that is what the principles are trying to convey. So first thing, I think, defect prevention over defect detection. As I was saying, the cost of fixing a defect is going to be really high. So any practice that is helping in preventing, starting from whatever we were talking about, like the Three Amigos process or the linters or running the tests on the local machine. So anything that is actually going to help us in preventing the defect, that needs to be prioritized. And another as principle is communication and collaboration. Like I was saying, many teams that I've seen have the testing team as a siloed team, and testing cannot be a siloed activity. So testing has to be a collaborative activity where the requirements have to be vetted out clearly, or the integrations has to be understood properly, and the layers of the applications which are talking to each other, what is the data flow, what are the components that are talking to each other to finish the application functionality. All of those needs to be communicated, and the collaboration of feedback, passing on the feedback from the testing team to the developer team and to the analysis and folks is very essential. So communication and collaboration, if it is hampered, the quality goals cannot be achieved at all. Empathetic testing is another principle. So testing is all about wearing the end user's hat. At the end of the day, we are representing the end user, making sure that the end user is able to actually like the app in the way that we think that makes sense. So wearing the hat and understanding the end user personas and making sure that we are able to simulate some of the test cases from their perspective is one of the important principles. Micro and macro level testing. So this is another thing that very important is testing cannot happen only on the very higher level. Like testing cannot be viewed only at a top level. Just look at functional user flows and I'm done. but testing has to be at, it has to be constantly zoomed in and zoomed out. If you are actually making an order, making sure that the order total is calculated properly with different kinds of inputs, right? Like with a negative input, some decimal, that's like at a very micro level. So testing at that micro level, and also testing at about integrations and components talking to each other, downstream system, that's like the macro level that I refer to here. So these constant zoom in and zoom out needs to happen while we are approaching testing. Fast feedback. I cannot emphasize how important it is to give fast feedback to the team, so that there is no, because nowadays we see that there are a lot of uh, people who are integrating in a quicker fashion. There is so much code that is getting added on a daily basis. So making sure the feedback for the code that is getting added on a faster fashion will avoid a lot of rework. Continuous feedback, and also this is important. Usually fast feedback, I think you can view it as, okay, actually I will do it once in 2 weeks, and that is fast feedback for me. But that's not, it has to be continuous. Like fast feedback mechanisms has to be backed by continuous feedback. That is what we were talking about earlier, right? Like in how iterative really every user story and every commit and is actually getting the necessary feedback in multiple loops. So once the developer pushes a single commit on a particular feature, the feedback loops kickstart through the automated tests that we have spoken about, and the feedback is gotten in a continuous fashion, so that uh, as I said, the defect is actually not let percolate to other environments and the cost gets high. Measuring quality metrics is very, very important. That's the last principle that I would like to emphasize. So anything that is measured, right? Like for example, the product has some OKRs. So we try to measure the OKRs because we want to make sure the product is meeting, and we actually develop the features that is very relevant to the OKR. So if quality is going to be important, then we need to measure that and make sure that the metrics are met on a continuous fashion, will basically align the team towards the certain towards quality. So usually quality is left out as an entity that is invisible, and we just focus on following certain practices and then leave it there. The underlying assumption is, if we follow these practices, if we follow these tools, and probably everything is going fine, and I believe that I build quality. But most often the understanding of individuals are very different, and when it is not measured, there is always a possibility that there are gaps. So measuring quality metrics is a very key principle, and there are different ways to measure it. There are different parameters to measure it. So these are like the 7 guiding principles when it comes to testing. So all of these are actually discussed in the full stack testing book. So basically, all the elements that we spoke about, the process, the techniques and tools, and also practical examples of how to actually implement those techniques, the fundamentals of those techniques, and the step-by-step guide of the tools, and also the approach that we have to have in mind to solve the problem is all discussed in the full stack testing book, if you want to explore this topic further. So thank you for listening, and that's it from me today.
Hey Gayatri. So yeah, first of all, thanks for such an insightful session on full stack testing. And we have a few questions, and I'll display them on the screen.
Sure. At which stage privacy leak testing should be done? So privacy, I think once again it is a huge topic, and as I was saying, it's not just at one particular stage that we need to be looking at. So the feedback loops have to be on a continuous basis. So we need, like I said, the pre-commit hook that we have actually checks for the secrets to be there. That is one kind of a feedback, so that you don't check in the passwords. And there is another kind of, as you move to the another stage, you have SaaS tools that are actually looking at all these aspects. And there is also DAS tools which does all the penetration testing. So it's a continuous process, I would say.
I hope that answers your question, Hitesh. And second, we have this from LinkedIn.
Is micro and macro level testing comes under white box or black box testing? So micro and macro level testing, once again, I view it in a way of it needs to be done both through the lens of manual exploratory testing and also from the lens of automation testing. So when we are doing manual exploratory testing, the mindset has to be to zoom in and to zoom out. That's what I mean by micro and macro level testing in while doing manual exploratory testing, right? So for the example that I was talking about, so if we are actually doing testing for order calculation, so we are actually adding a lot of products and making sure that the shopping cart is showing the right order calculation with taxes. So the micro level testing would be to go about all the test cases that will lead to order calculation, the decimal values, the null values, the negative values, and all of those are zooming in at a micro level on the order calculation functionality alone. And we are doing the manual exploratory testing there. And macro level testing is the user flows, integration flows, like making sure the user is able to successfully place an order and the warehouse management system is triggered to check for availability. All of those are like end-to-end macro level testing that can be done at the manual exploratory testing phase. So during manual exploratory testing phase, it doesn't come under white box. But if you are writing automated tests, then it means that micro level tests are unit tests, contract tests, and all the sorry.
Yes, Gayatri?
Sorry, I was hearing some echo. Okay. So all of this are actually at the code level. So and anything up the macro level, the API testing, end-to-end UI driven testing are on a deployed environment, and you can say it is black box.
I hope that answers your question, Ramakrishna. And those are all the questions we have, Gayatri. So
Sure.
if you
Thank you.
guys have any questions for Gayatri, you can reach out to her, and you can find her LinkedIn and Twitter handles in the comment section and also in the description of this YouTube video. You can reach out to her with any doubts you have. And Gayatri, if you could share the link to the book in the comment section, it'd be great so our viewers
Sure.
can also benefit from it.
Sure. And thank you for the questions, folks. I hope it was useful. So let me paste the comments. I don't see the comment section for some reason.
You can just paste in this private chat. I'll paste it on your behalf.
Sure. Cool. Thank you.
Thank you, Gayatri. I've pasted the link to the book in the comment section. You can check it out. And before we go ahead with our demo, I'll once again remind you that we have a quiz today post this session. And the link to the quiz has been pasted in the comment section. You can register for the quiz and upskill yourselves. And winners get gift vouchers. And we also have an upcoming tournament, and link to that can also be found in the comment section. So do register and upskill yourselves. All right, so without any further delay, let's bring Jim to the stage. Hey, Jim.
Hello again. Yeah, thanks to
Yes.
good to go.
Yes, over to you, Jim. Good to go.
Thanks a lot. Thanks to Gayathri for that presentation. That was great. And the book is definitely a fantastic resource for understanding modern full stack testing for sure. Great resource. So yeah, let's jump into a demo. So Harness, as I was sharing at the beginning, we're a software delivery company. Continuous integration is just one piece of what we provide for a service. And so I'll be sharing a demo with a MERN stack that we've written, showing how to test a component of this application. So real quick, I want to talk about Harness's two continuous integration products. So why do we have two? So we have both Drone and Harness CI. So Drone is an open source project that was started in 2012. Harness acquired Drone in August of 2020. Drone's the reason that I joined Harness. I've been a Drone user and contributor since 2018. Drone is a self-hosted and self-managed open source offering. So that's great for a lot of companies that need those capabilities versus Harness CI. Harness CI is a SaaS solution. So Harness will manage the infrastructure for you, so you don't have to. Harness CI has a free tier where if you sign up, you can run up to 100 builds per month with no charge. So these two products appeal to different types of organizations, and each contributes features to each other, actually. So, for example, Drone recently had some user interface improvements, which came from Harness CI. And Harness CI has had some support added for Drone pipeline plugins. So they can complement each other really well that way. So that's the background behind why we have two products. But today I'll be focusing on Harness CI, since there's no need to run any infrastructure yourself. You can just create an account and start running continuous integration pipelines right away. So let's jump into this. So in this demo, like I said, I'm going to show running integration tests for this MERN stack application that myself and some other developer advocates in my team have been working on. MERN stands, if you didn't know, excuse me, MERN stands for each component that makes up the application. So MongoDB, Express, React, and Node. All right, so this is the code. So we have an organization in GitHub, Harness Apps, where we're keeping these applications. So this MERN stack has a database behind it, MongoDB, and then it has a server component, which is the back end, and then a client component, which is the front end. So what I'll be doing is, so I forked this repository into my own account. So that's here, and I'll show why I forked it in just a moment. So from here, this morning I created a brand new account at app.harness.io. I just had to sign up with my email address, and this is the first screen that I'm greeted with. I can pick from one of these four modules. So of course I'm going to pick continuous integration. And it brings me here. So I can click create a pipeline. Now, like I said, Harness manages the infrastructure for you. So there is a little bit of time where it will provision the infrastructure behind the scenes where my pipeline will run. So that takes just a moment. Could take up to 2 minutes. Usually takes about 1 minute. So the kinds of tests, maybe I can jump into while we're waiting. So we'll be looking at the server component here. And the test that we'll be running will come from this file here. So like I said, these are integration tests versus like a unit test would be testing code in isolation, right? A function maybe would have a unit test that just exercises that function and tells you if it's behaving as you expect. Integration tests are when you have multiple components talking to each other and you want to make sure that they're behaving well together. So integration tests for this, the server component involve bringing up the Mongo database behind it and the server application itself and sending some traffic and making sure that it behaves the way we expect. In this case, 2 endpoints, /record and /record/add. Maybe we'll come back to that in a minute. Oh, good. Here we go. This is provisioning complete. So now I can choose what repository I want, excuse me, that I want to use. Of course, I'm using GitHub. So I'll select that. And for authentication method, I only have the access token option. So I've generated this beforehand. And if you've never generated a GitHub access token, you can click this link and it would tell you how to do it. So I've pasted it in. It's nice that Harness, at almost every step of the way, Harness will allow you to test your configuration to verify that you've done it correctly. So you'll know, early on if you've made a mistake. Then click the next button. Harness is going to go out and see all of the repositories that my GitHub user has access to. So I think I have a few different organizations. So this takes a few seconds and there we go. So now I'm going to filter Mern. So here's my Mern stack example fork I was showing earlier. And click create a pipeline. Great. So now Harness CI just gave me an example pipeline based on that repository. If I look at each tab here, so the infrastructure where this will run, of course, I'm not having to manage it. I could if I wanted to. Right now, Harness is going to do that for me. But if I wanted to run my own infrastructure in AWS or Kubernetes, I could do that. Click over onto the execution tab, and this is where we'll see the pipeline steps in this stage. So you see I have just a build stage now. I could even have multiple stages. I'll just have one stage for this demo. It gave me a welcome message step as an example. So very simple here. It's just going to echo out, hey, welcome to Harness CI. And you'll see here that it's running in a Docker image, and in this case, the Alpine Docker image. So I'll leave that step there and add a new step. So this is all very visual. So it should be very easy to determine what you should click at each step or for each step. So for what I'll be doing here, I just want the run step. So I've clicked that, and I'll call this test Mern server. So now Harness needs to know how to retrieve. So I'm going to run a step in a Docker image, and Harness needs to know how to authenticate to retrieve that. First time I went through this, I thought, well, this is really extra work, isn't it? Why do I have to authenticate to pull a public Docker images, public Docker Hub image? But this is actually a good thing. So let me click. I'm clicking a bit too fast here. I'm creating a connector. So anytime you have to do any interaction with something external, there's always a connector involved in Harness. So in this case, it's a Docker registry that I'm connecting with. So I'll click that. And this is going to be Docker Hub. And I have to provide the registry URL, which is index.docker.io/v1, my Docker Hub username, and secret. So this is similar to how I had to provide authentication for GitHub to pull that. This I have to provide a Docker Hub token as well. So I'll just call this Docker Hub token. And I've already generated this earlier. Paste that in. Great, so this looks good. And I was starting to say why this is a good thing. So yes, it's a public Docker image. You can pull it anonymously without authentication. But if you'll remember, hopefully, if you were in the tech world in the end of 2020, Docker Hub started more aggressive rate limiting. So it actually really impacted a lot of CI/CD pipelines that were depending on anonymous Docker Hub pulls. So I believe the limit, there's some very low limit now. It's a number of hours, a short number of hours, you only get maybe 100 anonymous pulls of Docker images. So you can run into that very quickly. So the bottom line is it's good to authenticate when you're doing interactions, certainly with Docker Hub, but other resources too, in any step of your CI/CD pipelines to avoid potential issues like rate limiting, because that can be really disruptive to your CI/CD pipelines when they start failing, when all of a sudden you're being rate limited and denied access. So that's an important tip, I feel. So here we go. I've got my connector set up, my tokens in there. I'll continue. As you can see, it's going to run this, the pull of this Docker image and the run of my test on any infrastructure that I want. Right now, I'm fine with letting Harness manage that infrastructure, so it's going to run on the delegate that they've created for me. Again, another test is running, and it's successful. So the credentials I passed in were valid. There's a minor UI bug right here where I have to click away and back for it to show up. But here it is. If I click on that, so great. So now my container registry Docker Hub is filled in. So now I need to provide a Docker image where this will run. And I'm going to pick the node 16 Docker image. And give it my commands. So this repository has the server and client. So this test is for the server, so it will change into the server directory, run yarn install, and then yarn test. This is a MERN stack, so it's node. So the tests are using node, and yarn is a wrapper around npm, I believe. So that's it for this here. So briefly, I just wanted to emphasize how nice it is that these days we can use Docker images. I'm old enough and been around long enough to remember when you were always limited by the operating system and what was available and previously installed on the whatever instance or virtual machine you might be running on. Having the ability to run tests from whatever Docker image is right for you is such a game changer these days. So I can, of course, in this case, just pick the official node Docker image. If I had a lot of complex dependencies, I could build my own Docker image and run my step in that instead. So it's so nice to have that capability these days. So I clicked apply there, and this is good. So I'm going to save it, and I'm going to kick it off and hit run. So this is a manual run, so it needs to know which branch to pull down. So I'm running this manually. Harness does have the ability to work with webhooks and trigger things like pull requests or commits to certain branches automatically. But for right now, a manual run is fine for this demo. So again, what is happening? A failure. This is demo fun. Let's see. Harness image. No delegate found. Okay, I think I've run into this before. It's an issue with maybe how long it took me to run to get to this point, and the delegate went away. Infrastructure. When in doubt, run again, right? Can I say skip? I'm going to try skipping that pre-flight check. Okay, great. So fingers crossed that this is going to work now. So this interface is really nice. It shows you very clearly where it is in the process of your pipeline, where a clone of my repository happened. That welcome message that I didn't remove that was there for me ran right here and echoed out, welcome to Harness CI. And now the test MERN server step is running. So I can expand this a bit. Actually, I can click to the console view, which is much clearer, I feel. Great, so Yarn install is running now. So this is going to download all my node module dependencies that are needed for my test and then run the tests. And like I said before, this is actually bringing up a temporary Mongo database running in memory and the server process itself, and then running those two tests that I shared previously, the /record are let's look again. /record and /record add. And looks good. So we reached the end of the tests and everything passed. So hopefully that gives you a good overview of what's possible in Harness CI and how easy it is to get started. So I put together a bunch of hopefully helpful links where I was just running that demo. Of course, is just app.harness.io. Harness, we provide some online learning resources at university.harness.io. We have one that is specific to CI at this link here. We have a lot of documentation at ngdocs.harness.io. NG stands for next generation. There is a current generation of Harness products that you'll see the first time you log in, but if you just click to the next generation is going to be replacing everything at some point. Everything you just saw was considered next generation that I shared. We have a community forum at community.harness.io. We have a Slack at harnesscommunity.slack.com, and there is a continuous integration room. We have an official blog where we have all kinds of content, related to CI/CD and lots of other topics. A lot of good articles on there, and we have a YouTube channel at Harness.io with lots of videos and demos and webinar recordings and meetups and lots of good stuff. So what's coming up in the series? Today was the webinar, and we'll be having the quiz following. So after this, for the next few weeks, we'll be having more quizzes and with weekly winners. And there will be a grand prize for that will be possible if you join each session. And there's just a lot of great opportunity for learning about full stack testing by being involved here. I mentioned 2 slides ago the Harness University. So this is what you can find there. You can find lots of different courses on CI/CD, chaos engineering, and many other topics. So these are product learning paths, role-based, and even on-demand webinars are available there. And with that, this brings us to the end. So here's some more information on Harness, and I really appreciate everyone being here. Thank you very much.
Hey, Jim.
Hello.
Yeah, thanks for such an amazing demo. We have a few questions here in the chat box.
Yes. Why should we use Harness CI/CD? Why not Jenkins, Circle CI, JFrog, etc.? Is there any migration tool available from Jenkins to Harness? 2 very good questions. So first of all, I just think it's great that there's so many options out there these days. There was a time where, I used Jenkins before it was Jenkins, when it was Hudson, and there was just nothing around those days. Jenkins was really your only option, versus today. There's just all, it's great to have so selection out there, but it can be confusing too. And so why would you want to use Harness CI? So the visual experience, I think, is not possible in any, or the level. I really enjoy the visual experience that I was sharing, how easy it is to click through and have that guided process versus Jenkins, where you're likely writing maybe a Jenkins file in your repository, or using like the Jenkins DSL plugin if you're doing anything automated, or or you're clicking through that UI, and it's just not the same experience for what I've experienced in the past. But I think ultimately, you're going to start with what you know. So if you have expertise in one of these areas, I can't argue that you shouldn't start there. Start there, and if you start to feel pain and frustration and limitations, then know that there are other tools like Harness CI and Drone, and and everything else that Harness CD and the other products that we offer. So the other tools in your that you mentioned, Circle CI, certainly we're a competitor with them. JFrog, I believe, is mostly artifact hosting. So Harness, I don't think we have anything around artifact hosting at the moment. So I don't think they would be considered a competitor to us. So we wouldn't be able to offer that. And migration tool, I'm not aware of anything. That would be really nice. That is definitely the kind of thing that I wouldn't be surprised if there's something in the works for help. There's just so many ways you can configure a Jenkins pipeline. It would be very difficult to provide a migration tool that would work with everything. So yeah, I don't have a good answer for you, but let us know, join our community, and say that if you let us know that that's something you're interested in, then that would be really helpful.
I hope that answers your question, Rajesh. And Mahendra is asking whether Harness is open source or a paid tool.
Yeah, so Harness, the software as a service platform, is not open source. There is a free tier for every product, so you can sign up and play with everything that we have available without spending any money. Drone is open source, so if you're looking for something that is purely open source that you can run on your own infrastructure, then Drone is the right way to go. You can look into the pricing model for Drone. If you're in education, or if you are a small company, I believe there's no charge. And then there's a community edition to Drone as well. And yeah, I'm a big fan of Drone. Please come and ask me questions about Drone anytime in our community.
Thanks, Jim. So there are still a few questions. I'll take some of them, and then we can go ahead to the quiz.
Okay. With Harness, is it possible to have cross-cloud deployment? Yes. So basically any commands, or any I shouldn't just say commands, because we do have like I mentioned, Drone has pipeline plugins, which are Docker images, and like I said, they work in Harness CI. So today we focus mostly on CI, correct? So for deployment, yes, I didn't get to talk about anything that's in Harness CD offering, but you can do similar things with running Docker images and in plugins that are compatible with both Drone and Harness CI. So yes, you could deploy something like to a Lambda function in AWS, and then same pipeline could deploy something off to Google Cloud, or maybe something to MongoDB Atlas, or basically anything you can run in a Docker container and anything you can run as a shell command, you will absolutely be able to do in any one of our pipelines. There are ways, but depending on what you're doing, there could be a plugin to make it easier, I think is what I'm trying to say. So short answer is yes, absolutely, you can deploy to multiple clouds, and depending on what you're doing, there could be multiple ways to do it.
The next question is how to integrate pipeline to every commit in GitLab, irrespective of branch.
Yeah, I don't know how to do that exactly. I know that would be possible. I know how you would do it in Drone. Drone does have GitLab support. Harness also supports GitLab. So in Drone, you actually don't specify anything. you can if you don't specify a branch, and this is getting into the Drone YAML syntax, which we didn't talk about at all, but I can tell you that if you were writing a drone pipeline YAML file, if you just don't specify a branch, then it will execute on every commit in every branch, which is sometimes desired, sometimes not desired. You can specify, individual specific branches or branch patterns or, pull requests, that sort of thing. So another case where I gave a long answer. The short answer is yes, you can do that. And the long answer is I've never done it, but I'm sure it's possible.
All right, now we have the last question, Jim, from Ramakrishna.
Okay. Yes. So is a free trial version available? Yes. So if you sign up at app.harness.io, everything that I just shared is certainly free. You can run, I believe, up to 100 pipelines per month in our CI product for free. And each of our other modules also has a free tier that you can use to get started without having to pay anything.
Super. I hope that answers your question, Ramakrishna. And if you guys have any more questions for Jim, you can reach out to him on his LinkedIn and Twitter. We have put the links in description, and they will also be pasted in this live chat. And Jim, if you could also join the stream and answer any questions if they have, it'd be great. And
Okay.
Thank you, Jim, for such an insightful demo and telling us about Harness.
No, thank you very much for having me.
Yes, thanks, Jim. Bye.
Bye.
So before we go further to the quiz, make sure you've registered for the quiz first. And I'll be again pasting the quiz link here in the live chat. Make sure you've registered. Make sure you've signed up and registered on the Quiz Hub platform. We'll wait for 1 minute for if someone is left out. And meanwhile, I'll give you some announcements. As Jim mentioned, over the next few weeks, we have Harness has aligned a tournament for you where you can upskill yourselves. You can take part in quizzes. The quizzes are every Friday at 5 p.m. and you can take part in the quizzes. Every week there are prizes. There is also a grand prize. There's Apple Watch. You can do register. Tell your friends. The link to the tournament is pinned in the live chat. And we'll be starting soon with the quiz. And before just we start, just remember 4 points. There are some do's and don'ts of the quiz. So for a smooth experience, we recommend you to be either on Google Chrome or Safari. And in case you get dropped out, please join as soon as possible. So if you do get dropped out and you join, you will be allowed to play, but from the next question onwards. And we request you to not be on VPN. It might cause some lags issues. And avoid refreshing your screen until and unless it is very, 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 very important. All right. So we have. Okay. So we are going to start with the quiz. The first question will soon be on your screens. All right, so the time is up. And you can see the correct answer on your screen. The correct answer was make it a habit. And around 92% of the participants answered it correctly. That's awesome. Moving on to the second question. It will soon be on your screen. All right, so the time is up. The correct answer was true. And again, 93% of the participants answered it correctly. And if you wish to learn more about harness, you can check all the learning resources that Jim has mentioned. And I'll be also pasting the link to the website. And you can also take part in the tournament because you will need to upskill yourselves to win amazing prizes. Moving on to the third question now. The time is up. All right, so the time is up for the fourth question. And answer was true. Around 85% of you answered it correctly. Moving on to the fifth question. It will soon be on your screens. The time is up. correct answer you can see on your screen. Moving ahead to the sixth question. The time is up. And the correct answer was Node.js. Around 73% of the participants answered it correctly. So the time is up, and the correct answer was true. Going to the eighth question. All right, so the time is up, and you can see the correct answer on your screens. Moving ahead to the second last question of the quiz. The time is up, and correct answer was false. All right, so the last question. All the best, everyone. The time is up. The correct answer to this question was testing at the beginning of the software development cycle. and around 63% of you answered it correctly. And with this, we have come to an end with today's quiz and today's meetup. The top 5 winners of this quiz who top the leaderboard, the top 5 will be given gift vouchers worth 200 INR, and they will be reached out to through email, and they will be reached out to in a couple of days. And so yes, this was the building a full stack CI/CD pipeline, building and testing a full stack CI/CD pipeline. Thank you all for joining. And as I mentioned earlier, there will be a tournament and more amazing prizes to be won. So do register. You can find the link has been pinned on the live chat, and it will also be pasted again here. So I'm pasting it. Yes. So yes, so do participate in the full stack testing and GitOps challenge and upskill yourselves. And thank you all for joining and have a wonderful evening ahead.